Okay, we'll do some more on the topic 7 worksheet here. Um, I had gone over our list of laws of logarithms in the video for the other class, and so we did a little bit with that here in problem, like these previous problems. So we'll do 2 more examples of that. Problem 16, expand log base 5 of 25x cubed over y to the 4th and give your answer without exponents. All right, that's how the book will want it. So I know that I'm dividing terms in this logarithm, and law 2 says that if you're dividing terms, you can split this logarithm into 2 logarithms where the operation would be subtraction. So that's what I've done here to start, subtracting these 2 logarithms. Now, 25 times x cubed means I'm multiplying, of course, and so law 1 is saying if you're multiplying the inner terms, you can split that into 2 logarithms where you'll be adding them together. So I'm going to split this first logarithm into 2 more. You got log base 5 of 25 plus log base 5 of x cubed. Log base 5 of 25, well, 25 is the same as 5 squared, and I know that powers can come out of logarithms, right? That's law 3, so this power of 2 can come in front. 2 times log base 5 of 5, log base 5 of 5 is 1. 2 times 1 is 2. Everything else would stay as is here. So here would be my answer. Oops, it says give your answer without exponents. So actually I would need to take this a step further. Sorry about that. 2 plus log base 5 of x cubed means that I'd want to factor out the 3. 3 is an exponent, and so bring that out front. You got 3 times log base 5 of x, and then minus 4 times log base 5 of y when you bring out the power of 4. Okay, that actually should be the answer here, not what I have circled. So, yeah, sorry about that. Okay, problem 17. Write this expression is a single logarithm. Okay, well, I'd want to take care of the multipliers here. 4 is a multiplier, negative 1/3 is a multiplier. Okay, let's bring those powers inside the logarithm so that they're a power of the inner part. We'll keep the first logarithm as is. Now 1/3, when you bring that into the last logarithm there, so that's a power of y to the 1/3, that's the same as the cubed root of y. So I'm using radical notation. If you were to use fractional notation, that would also be fine. So now that we've taken care of the multipliers there, and we've got the same base on all 3 of these, we can go to the answer. Okay, I'm adding 2 logarithms with the same base, so I'd want to multiply the inner terms. And then I'm subtracting log base 3 of the cubed root of y. Since I'm subtracting, I want to divide by the cubed root of y there when I go to get my single logarithm. Problem 18. The lifespan of a sample of robins was studied. The equation that you see there, it calculates the number of years y for x% of the robin population to die. How long will it take 70% of the robins to die? Okay, well, x is the percent, so I would just simply plug in 70 and simplify, so I get y. And I've done that. Okay, plug in 70. 100 minus 70 is 30. And so now you can go to the calculator and type this in. We got 2 minus log of 30, and then divided by 0.42. I'm getting 1.2, if you go nearest 1 decimal on that. So roughly after about 1.2 years have gone by, 70% of the original robin population would have died off there. Okay, problem 19, I'm solving some equations. Now, many times when you're solving a logarithmic equation, you want to be using the definition of a logarithm and or properties of logarithms at some point during the calculation. Okay, so you'd want to keep that in mind here. Now remember the definition of a logarithm. Y equals log base a of x means that x equal a to the y. And that's also on this other sheet that I gave. That was important statement number 2. Okay. So that's what I want to do here. In part A, I want to get rid of this logarithmic notation. So 3x minus 2, that's inside of the logarithm. I want to keep that all alone now on the exponential. 2 is the base, and so it's going to be the base of the exponential. 4 is my y value, so I'm going to have 2 to the 4th on the right. 2 to the 4th is 16. If you add 2 and then divide by 3, you get x equals 6. Okay, now you can sometimes get extraneous solutions with logarithmic equations, so you want to make sure that you're checking your answers. If I plug in 6, 3 times 6 is 18, minus 2 is 16. So then the next question is log base 2 of 16 equal to 4. Well, log base 2 of 16 is the same as 2 to the 4th. And that's how I'd want to look at that, because then the 4 can come in front of that logarithm. Log base 2 of 2 is 1, and 4 times 1 is 4. 4 equal 4, that's a true statement. Okay, so 6 is going to be kept. Here's another one, part B. I'm solving for x, so let me subtract 10 from both sides, and then I'll get rid of the logarithmic notation there. Again, using the definition of a logarithm. So 8 minus 3x, that's my input. That's going to be all alone on the exponential. 5 is the base. That's going to be the base of the exponential. 3 is my y value. Okay. 5 cubed is 125. If you subtract 8 and then divide by negative 3, you get x equal negative 39. Are we going to keep that negative number? Well, remember that the overall value in a logarithm can't be negative. Now I'm getting a negative x value. That doesn't matter. If you take 8 minus 3 times negative 39, that will be okay, because 8 minus 3 times negative 39 gives you positive 125. Okay, so we still have log base 5 of a positive there. Now log base 5 of 125 is the same as 5 cubed, and if you bring out the power of 3, log base 5 of 5 is 1, so we get 3 with that part. Okay, 10 plus 3 is 13, that's true, so negative 39 is going to be kept. Be sure that you're checking your answers for extraneous solutions, because they do sometimes come up with logarithmic equations. We'll do problem 20 next. We're solving some more equations here. And, okay, now in part A, I want to combine these two logarithms to a single logarithm by multiplying the inner terms. That's using law 1 on that list of logarithms there. And so, okay, I'm multiplying x plus 6 times x plus 2. I FOILed that out here. And now I'm going to plan to get rid of the logarithmic notation by using the definition of a logarithm. X squared plus 8x plus 12 is my input. That's going to be all alone on the exponential. 5 is the base. That'll be the base of the exponential. 1 is my y value. 5 to the first is 1. Subtract 5 from both sides, and now we're looking at a quadratic. X squared plus 8x plus 7 equals 0 is going to factor nicely as x plus 1 times x plus 7. Set each of those equal to 0, and you get x equal negative 1 or x equals 7. Okay? We'll want to check that. Now, negative 7 is no good, because if you plug negative 7 into the original, negative 7 plus 6 is negative 1, and you can't take log of a negative. So immediately we can cross that out. Now, is negative 1 going to be okay? Well, negative 1 plus 6 is 5. Negative 1 plus 2 is 1. Log base 5 of 5 is 1, and log base 5 of 1 is 0. Log base anything of 1 is 0. 1 plus 0 is 1, so we do get a true statement there, and it looks like negative 1 is going to be kept, negative 7 is going to be thrown away. Part B, solve for x. This 2, let's bring that inside the logarithm so that it's the power of the inner part. And then I'm subtracting logarithms with the same base. Let me get a single logarithm on that by dividing the inner terms. And then I would say at this point, let's use the definition of a logarithm to lose the logarithmic notation. X plus 7 squared all over 9 is my input into the logarithm. That's going to be all alone on the exponential. 3 is the base of the logarithm. That's going to be the base of the exponential. 2 is my y value. 3 squared is 9. And if you multiply both sides by 9 here, that'll get rid of the fractional form that's on the left. 9 times 9 is 81. And then you'll take the square root of both sides. Okay, and of course, don't forget about the plus or minus when you do that. X plus 4 equal plus or minus 9 means that x is 5 or x is negative 13 when you subtract 4 from both sides and simplify. Okay, negative 13 is not going to work, right? Because negative 13 plus 4 is negative 9, and you can't take log of a negative. 5 is going to be okay, since 5 plus 4 is 9, and log base 3 of 9, let's see here, log base 3 of 9 is, I can just do that on this sheet here. 9 is the same as 3 squared, right? So the power of 3 can come in front. Excuse me, the power of 2 can come in front of the logarithm there. Log base 3 of 3 is 1, so 2 times 1 is 2. Times 2 is 4. And then log base 3 of 9, we just said that's 2. 4 minus 2 is 2. And 2 is the number that we see on the right there. So 5 is going to be kept. Negative 13 is extraneous. Part C, solve for x. Okay, so I'm subtracting 2 logarithms. The natural logarithm, that's fine. Of course, the laws all apply to any base. If we get a single logarithm by dividing by the inner terms there, then here's what I have on the left. Now I've got ln notation on both sides of this equation, so I can remove the logarithmic notation and set the inner terms to be equal. That was the last statement there on that sheet that I gave you. You can remove the logarithmic notation and set the inner terms to be equal, as long as it's the same base on both sides, okay? Which it is here. And now, we no longer have logarithmic notation there, which is good. Okay, multiply both sides by x plus 2. That'll get rid of the fractional form that's on the left. 4 times x plus 2 is 4x plus 8. If you subtract 3x and then subtract 8, x equal 3 would be the answer there on that one. Okay, part D is, how about we'll do part D and we'll stop the video. We're solving an exponential. Now, I was solving exponentials earlier in the notes, but in those problems, we were able to get the same base on both sides. Of course, you can't always do that, okay? And in this problem here, like, there's no easy way to rewrite 6 as 4 to some power or 4 as 6 to some power. When that situation happens, we want to get logarithms involved in the calculation. And usually we use the natural logarithm. So I'm going to start by taking the ln of both sides. That will allow me to bring the powers in front of the logarithms. Be sure that you have parentheses around both of those, since you want to distribute ln 6 into these two terms and then ln 4 into these two terms. And so I've done that on the next line. Anything involving x I'm getting on the left. All the other numbers I'm getting on the right. So I'm subtracting ln 6 from both sides, and I'm subtracting 2x ln 4 from both sides to get to this next line. X is in common to these two terms of the left. You can factor that out. And that's going to leave you with ln 6 minus 2 ln 4. ln 6 minus 2 ln 4 is just a number, just like 5 is a number. Okay, so I want to divide both sides by that number. That way x is all alone. And we've got x equals negative ln 6 minus ln 4 all over ln 6 minus 2 ln 4. That would be the exact answer. If you were to type this into the calculator, here's how that would look. It's going to be negative ln 6 minus ln 4. And actually I'm going to want parentheses around this entire thing here, since I want to make sure that the calculator divides at the very end. Make sure that you have that. If you don't have the parentheses, you won't get the right answer there. We're dividing by ln6 minus 2 ln4. Okay, and hit enter. And I'm getting 3.24 roughly if you go nearest 2 digits on that. Okay, and be sure that you pay attention to how they want the problem written. You know, so, in some of these they'll want the exact form, and on some of them they'll want the approximation. Be sure that you're reading that.